What's up, Toad Farts? I got an integral for you guys. I was doing some practice and I came across this problem from MIT Open Course and it puzzled me at first. I tried doing it the way that I usually do it and that was not working. And then I checked the solution and I was like, oh, wow, their bounds are off. That has to be a typo. And then I just realized I wasn't thinking big brain enough, and I'll show you what big brain means when you do this line integral. I personally found this one a very fun, appealing line integral to do. Well, first, let's just rewrite f in terms of t. So if we have 6y, that's going to turn it as 6t cubed. And then if we have x, well, that's going to turn just into t squared. Okay, so not so bad yet. But what makes this really fun is the fact that this is x and y, but this is x and y here. So what we actually got to do, well, actually, before I do that, let me just write the integral, and you can try to think in your head of how you're going to get that. Get our bounds. So we'll just call our bound c for now. Well, remember, we always write this as 6y. Let me go even one more step back. It's usually in the form p dx q dy, which in our case is going to be what? It's going to be 6t cubed, and dx is going to be 2t dt. And then we have, right, q, which is t squared. dy is going to be 3t squared. 3t squared dt. And then if we simplify this, we can rewrite this whole integral real quick. So 6t cubed times 2t, 12t to the power 4. And they both got dt, so we're going to factor that in the back real quick after. So t squared times 3t squared, well, that's 3t4 dt. And then we could see that we could even write that once more just to make it just the nicest way possible. 15t4 dt. Now, if you saw it, like if you had an idea of how to do this, leave it in the comments, right? I messed it up the first few times and I was just puzzled. I really thought they had a typo, but they didn't, because MIT doesn't make mistakes like that. Okay, well, let's just say at first we have x and y, and we have a point 1, 1, and we have 0.48. Okay, but then we could use the fact that x is equal to t squared and y is equal to t cubed. But then that's not that useful to us, really. Well, just go one step at a time. We could just write this 1t squared and 1 is equal to t cubed, and we could write this as 4t squared and 8 is equal to t cubed. Okay, now it's kind of useful, and if you see it, well, everything is t, right? So there's only one variable, and there's 4 numbers equal to a function of one variable, right? Well, there's 4 cases, 4 equations, all functions of t. So we could see that for this case, all of this, well, t has to equal to 1, right? For both cases to be true, particularly. And in both of these cases, well, t has to equal to 2. Now you're like, oh, can't t equal negative 2 over here? And you're like, yeah, I can, totally can. But can t equal negative 2 over here? No, it can't, right? It won't equal 8. So then we just say that our bounds for t, as you can see, is from 1 to 2. So now we can actually complete our integral, whereas 2 to 1, 15t4 dt, which turns into 15 over 5 t5 2 to 1, which, as you know, is 3. Okay, now 2 to the power 5, that's 32, and 1 to the power 5 is 1. Okay, well, this is 3 times 31, which is 93. That's all we had to do. So for me, it was this part that kind of stuck me. But if you saw it, good on you. Leave it in the comments.